What if I told you that the oldest story in the world, the story of death, is about to change forever? What if aging wasn't inevitable, but a disease we can cure? Scientists in labs across the United States are not just asking these questions, they are finding the answers. From reprogramming our very cells to unleashing the power of artificial intelligence, we are standing on the precipice of a new human era. An era where immortality isn't a myth, but a scientific reality in the making. This is the invisible poetry of life, made visible. For millennia, we have accepted a fundamental truth. We are born, we live, and we die. It's a cycle that has defined empires, inspired art, and shaped our understanding of meaning. But in the quiet hum of laboratories and the complex algorithms of supercomputers, a revolution is brewing. A scientific endeavor that promises to rewrite the very code of our existence. Today, we journey to the forefront of this revolution to ask, how close are we to achieving immortality? The secret to eternal youth might not be in a mythical fountain but within our own bodies, in the trillions of cells that make us who we are. In places like Silicon Valley, well-funded startups like Altos Labs and Retro Biosciences are pioneering a field called cellular reprogramming. Think of your cells like software that over time accumulates bugs and errors. This is what we call aging. Cellular reprogramming is like hitting a factory reset button. Scientists have discovered that a specific set of proteins can, essentially, rejuvenate aged cells, turning back their biological clock. Leading researchers in the US, like Harvard's Dr. David Sinclair, have shown that it's possible to reverse aging in mice. They've restored eyesight to the old and even helped them regrow damaged tissue. The goal is to translate this success to humans, to develop therapies that could one day erase the damage of age-related diseases like heart failure, Alzheimer's, and more. It's no longer a question of if, but when. But what if we could go even deeper? What if we could edit the very blueprint of life itself? This is the promise of gene editing technologies like CRISPR-Cas9. Our DNA contains genes that influence our lifespan. Some are beneficial, while others make us susceptible to the diseases of old age. American research institutions are at the forefront of identifying these longevity genes. The idea is simple, yet profound. Use CRISPR to correct genetic defects and even enhance our natural ability to resist aging. This isn't just about preventing disease, it's about fundamentally upgrading our biological hardware for a longer, healthier existence. The sheer complexity of the human body is staggering. To unravel the secrets of aging, we need a mind more powerful than our own. Enter artificial intelligence. Companies like In Silico Medicine are using AI to analyze massive datasets of biological information, discovering new anti-aging drugs and therapies at a speed previously unimaginable. AI is the super scientist, working 24/7 to solve the problem of death, and the tools of this new era will be microscopic. Nanotechnology promises a future where tiny robots, smaller than a blood cell, could navigate our bloodstream, repairing cellular damage, destroying cancer cells, and essentially acting as a personal internal army against aging. Futurist Ray Kurzweil, a prominent voice in the American tech scene, predicts that by the 2030s, these nanobots could make us effectively immortal. For some, the future isn't soon enough. This has led to the rise of cryonics, the practice of preserving a legally deceased person at extremely low temperatures, with the hope that future technology will be able to revive and restore them to health. Companies in the US, like Alcor, Life Extension Foundation, offer this service, a bridge to an unknown future. It's a gamble, a final bet on the power of science. But as we stand on this verge of achieving what was once considered divine, we must ask ourselves profound questions. What would a world of immortals look like? Would life lose its meaning without the urgency of a deadline? Who would get access to these technologies? These aren't just scientific questions. They are deeply ethical and human ones that we, as a society, must begin to discuss. The quest for immortality is no longer confined to the pages of science fiction. It is happening now, in laboratories across America and around the world. We are the generation that may witness the greatest transition in human history, from mortal to potentially immortal. The journey is fraught with challenges, both scientific and ethical. But one thing is clear: the invisible poetry of our visible life is being rewritten, and the next chapter promises to be the most extraordinary one yet.